In this talk, we will hear about supply chain vulnerabilities and misconfigurations in container. So in this beforehand, we saw a big overview, and we now choose these two subtopics. Yeah, I'm a DevSecOps trainer, architect, strategist as a freelancer. And let us directly dig into the topic because we're not having a lot of time. This is a very new, it's a very new thing, the vulnerability management framework. As an overview, we first have the phase discovery, then prioritize and act based on what we find. So in the discovery phase, we will test something, then we will say what do we want to tackle and what not, and then we act accordingly. So we have testing environment, that's very interesting. Where do you perform the tests? Then we aggregate the findings, the potential findings. Then we prioritize. Then we perform the action. And in the best case, we also have measurement of our actions. This talk is about a tool which I created with my partner, SDASE. And I will tell you the journey. So I start with very easy things which I implemented, and then it will get more and more advanced. That means it will get better from a security perspective, and it will be harder to implement it because it will take more time. So when you are using containers, Kubernetes, maybe multi-cloud or microservices, then this talk is for you. Typical problems are missing patch management, that leads, as we saw beforehand with the Jira example, to the option to exploit it, or you have misconfigurations. For example, we saw beforehand that there is an index of all files listed. That is something you want to disable, and that are things we can identify with these tools, the cluster image scanner. Basically, you're having on the right one production cluster or multiple production cluster. There we collect the running images, which are right now in production, and then we report vulnerabilities and misconfigurations to the developers in that containers, and also to operators. There, I wouldn't report known vulnerabilities, but for example, how old are the images based on a threshold, I notify the operators. This high-level overview. Now let us dig a tiny bit deeper. So you have the Kubernetes clusters. Then we have the cluster image scanner, which pulls the images from the registry. Then I put the findings in Defect Dojo. Defect Dojo is a vulnerability management system. There are also commercial alternatives, but I don't know one good open source alternative. And then I inform the teams, for example, via Slack or Rocket Chat or via email, and then the developers can act based on the findings they get. And on the next day, I perform a scan again, and then in case the vulnerability or misconfiguration is still there, they will get notified again. You might wonder, why is there no build pipeline here, which breaks? That is due to how known vulnerabilities are getting created. It's not a developer introducing a known vulnerability. It is someone else. We are using open source, and in that open source is a known vulnerability, and that comes asynchronous to our build process. So we need to analyze daily. Here, this is a bit more detailed. So here we have different container images which we would like to scan in the Kubernetes cluster. Then we have the image collector, which actually collects the images in the different clusters. Then we have the orchestrator orchestrating the different scans for the images we pull from the image registry, and then Defect Dojo vulnerability management system information to the teams. All right, I told you that I would like to talk also about the journey. So in the start, in 2017, I used dependency check. Who knows dependency check? Okay, there are 3, 4 hands in the room. So the dependency check scans for known vulnerabilities depending, for example, on jars which are in the file system. And then it tells you, yeah, after it detects, it is, for example, an Apache Commons library, it tells you which vulnerabilities are there for this version. I have integrated this in Jenkins, and in addition, I created an asynchronous jobs, which were starting the build periodically. So that's a very easy thing to set up. There is a Jenkins plugin. You just need to install that, and it works. But the process is not so cool. But that's how you can start. When we take a look back to the vulnerability management framework, in the testing phase, we now have the dependency check in the master. Then the aggregation is done via Jenkins. We can, in the Jenkins plugin, say we have a threshold. We accept 5 vulnerabilities which have the severity high. So based on that, we can prioritize. Yeah, what is the action when we have, for example, a false positive? A false positive means that dependency check detected that there is a vulnerability, but after analyzing it, we figure out it doesn't apply to us. So there's a false positive. And when we want to handle that, then we have to enhance the threshold. That's not a very nice way, because developers tend to enhance the threshold, but they never decrease it. So it always gets enhanced, but never decreased. So that is a very bad way of handling, but it comes with very low cost. And measurement, we have a graph. We can see the history of how many vulnerabilities are there and when have we mitigated by, for example, installing a patch. So that process was nice, as I said. So the next step was that I was using a vulnerability management system, Defect Dojo. I told you already that I don't like to break the build because it's asynchronous. And yeah, the next, when we take a look at this overview, here now we have a change that we have the vulnerability management system, and that means during the action here, what we can do is installing a patch that is a mitigation control, for example, but now we have more options to handle the vulnerability. We can, for example, say we accept this vulnerability, or we accept it temporary for 2 weeks, because I know there is a vulnerability now, but I don't have a patch available. I expect that I have a patch in my framework in 2 weeks, so I can temporarily accept this potential finding, and in 2 weeks I will get a notification again. I can also now mark a finding as false positive. And when it reruns the whole process and I have installed a patch, it will automatically be marked as mitigated. What I have in addition here is now better metrics. So what I can do is I can go to the Defect Dojo API and ask how many vulnerabilities are there per team, and are they open? And in case they are open, since when are they open? So that is called mean time to resolution. So how much time do they need to actually close a finding? That's very important, because developers otherwise tend to ignore findings after a while, because they're coming every week's findings and they have other things to do. So you need to find a way how to push the developers to actually fix these vulnerabilities. And one way is to make nice graphs showing which teams are good, which teams are bad. They can compare each other in a dashboard, for example, with a mean time to resolution. Afterwards, I realized that checking what is in the master branch might not be a good thing, so I used customize. So based on customize, I were using grep to identify which images should be in production. Should be in production. That doesn't mean that they're in production. It means they should be in production. It might not be in production because you need an approval because before it gets deployed, and the product owner is not working because he's ill, so he can't approve, or you have technical issues with the deployment. That doesn't happen often, but from time to time it happens. And then you're having outdated information. So that is one thing we have here in the pipeline, a technical issue. That's why it's not going to the production system, or the product owner has to approve a change, and he or she is, for whatever reason, not approving. Yeah, and then the state differs from what should be in production and what is in production. And what we want from a security perspective, always we want to check what is in production, what is potentially under danger, not what could be under danger. All right. Unfortunately, I realized that every developer team is deploying in a different way because we are having these DevOps thing where teams are independent from each other and they can do what they want. So that wasn't very nice. In addition, we had the problem, which I have shown, that what should be in production is often not in production. So then I came to the conclusion I need to have something which is scanning what is in the cluster, and then the cluster image scanner was born. So I'm detecting what is with these collector, which I have shown in the start, what is in production now, and that is what I'm scanning. That's a long journey here, as you can see. We are now already in middle of 2020, so that was 3 years. It will take you the same amount of time, or at least a year. It's not something you can do quickly. More often I go to a company and they say, let us do this, and this will be very quickly introduced, but it is a long journey. So what we have now, when we take a look at the vulnerability management framework, we now have here real-time production, and what we gain from it is that we now can better put the application in the context. So I know in which production cluster is it running. Is it something which is only available internally, or is it externally facing? So that are now things I can consider while I'm thinking, do I want to mitigate it now or later? Contextual information. In a container, in a cluster, we have different components. We have the application itself, we have the container operating system, and we have a host operating system. That's important to consider because, for example, dependency check is only checking the application, not the components of the operating system. In that small container, for example, the glibc is one example which you most likely will have. What I added after dependency check is other scans. For example, the image lifetime. That is something I do, especially when I go to a company where I have the task to assess the company. It's a very good indicator for patch management, because when the image lifetime is very high, then it means they are not doing patch management. I don't need to dig into what vulnerabilities are there when they haven't patched the application since half a year. I know there's something wrong with the patch process for this team. When you then discuss it with the team, they say, yeah, we only do something when there is a vulnerability, then you need to prove it, and that's why you need these tools to highlight what is actually in the image. Otherwise, from my point of view, you could just do patch management. In case that's very good, you achieved a lot already, but mostly, even with tools like Dependabot and Renovate, teams tend to not do that as good as they should, and then you need a way to detect that. That's why you test, from my point of view. To show to teams you really have a problem, you need to do something now. In case they would do patch management very good, for example, they patch every week, I would be very happy, but that is a dream for me. Because sometimes I get the question, why do we test? So I just wanted to explain. Yeah, so when we have an image, we have a project layer. That is what the teams are, where the teams are adding, for example, a jar or their PHP application. And under it, we're having other layers. And what I identified is there are teams which are very good with the first layer in the application layer, but they forget that they have in the Docker file a from where they define the space image. So the oldest I found last year was from 2018. So they always patch the application, but never the image under it. So I thought, okay, I need a test for that. They are all having different build dates here, so I can take a look at the build date. This is the image lifetime, and when we go further here, I take a look at the oldest image in there, and then I can I can identify which teams are not updating their base images. Base image lifetime is how I call it. That doesn't work always because we are nowadays having something called distroless, and in distroless you want that the image is as tiny as possible, and when you do distroless, often you want to have reproducible builds. That means when you build it today and you build it tomorrow, it should have the same hash value. That means you cannot change the date because the change of the date would mean that it's a new image. So with distress images, you need to you might get difficulties with these lifetime scan because then the image will be from 1970. So it doesn't work always. Then I identified, hey, not every team is using non-root users. Most of the team were using, most of the teams at one client were using it, but some not. So I created a check to scan for root. Currently, I'm checking for potentially running it as root because I'm not. I'm only checking how is the container configured, how is the container, how is the user in the Docker file, kind of. And not how the container is started. So that will be the next step to also check how is the container started in Kubernetes, because you might start it as a non-root user, even in the image as a standard would start as a root user. So that's why I say potentially. That also applies for the known vulnerabilities. I always say potentially known vulnerabilities, because we have to analyze if it really applies to us. It's very important when you talk with information security, because otherwise they will think it's always an issue, and you have to highlight, no, it's not always an issue. We first have to analyze, and then we know if it is an issue or not. Yeah, then I identified that sometimes there are new versions already available from the teams, but they are not using it for whatever reason. So I'm creating a small finding with a low severity that there is a new image of their own application available, that they haven't deployed it to production. Yeah, here now we have here the cluster image scanner with these different scans that I have shown to you. And very interesting now is the base image lifetime. Here I create again a dashboard for these both metrics, and then I reward the teams which are in the better half. So for example, with stickers or other things, so that the ones who are not getting the sticker or the other incentives, that they feel bad and also want to have it. You need to have incentives. There are some people which say we have a policy and that will work, but no, that won't work. You need to do something which motivates the developers to react to the findings. There are some teams which are doing it very good and some teams which are doing it very bad. When you do automatic patch merging, so you have Renovate and you say to tell Renovate or Dependabot or whatever, please automatically merge these patches after, let's say, 14 days. These teams are mostly better than the other teams. because they automatically patch. So that means they automatically have less vulnerabilities. So that means in the statistics, they are always better. You also can have something in between that you say, I have a trusted framework, and for that I always patch, and for the other the other dependencies I don't patch. That is a kind of a middle way in between. So when you say I trust Spring, and I always want to patch Spring, then you can do that, and you don't patch the other dependencies which you are having. Here, then, nowadays you often have, no, you more and more have supply chain risks like crypto miners, which are installed in your dependency, which you would like to install. So I also have a malware scan, which scans the containers for malware. You could argue it's a bit late here. You would like to do it in the pipeline, but there you get the problem that malware scanners mostly use pattern matching, and often it takes up to half a year until they have the pattern for specific malware or crypto miners. So, from my point of view, it should be in you should scan the production images. Yeah, and then after I used dependency check for a long time, we had the vulnerability log4shell. So I knew there is a vulnerability which is only available for log4j in a specific version. But what I couldn't do is asking in which components do I have this log4j running in my specific version? So what I need is an asset inventory. An asset inventory in which I have everything which is in production, all the components which are in these different images. So that I can look up log4j in version X is in this and this containers on that and that cluster. Yeah, and that is what dependency check is doing. In addition, it also scans for vulnerabilities. So I could remove dependency check and use dependency check. Dependency check works a bit different because it's a server-side component, because you want to look up in your asset inventory. Dependency check you just run and then it's done, you get a report. Dependency check is a component it's a server-side component which you have to run in your Kubernetes cluster. Yeah, and then you're ready to go. Here's nothing new. Yeah, software inventory. I think I explained already what it is. Performs vulnerability scans. It has one disadvantage. It only performs the scan when you upload a new software bill of materials or once a day. So when you have these log4shell thing, which is a critical vulnerability, you don't want to wait until the next day. You want to know it now. You would like to perform a rescan. That is something you don't have, so you would need to run the whole process, which takes a while, or you need to look up, do I have log4j in that version? So that is the only thing which has a small disadvantage. You would need to start the whole process, which will take a while, because you need to fetch the images and you need to scan the images. Depending on the size of your cluster, it will take a while. You can gather software builds of materials with multiple tools, for example, CDXJam, that you can do in the build pipeline, for example, or in case you just have an image, for example, third-party images, then you can't rely that there is a software bill of materials in the image, so you can run Sift as one example. This is a simple overview. In detail, it gets much more complex, but to give you an idea, optionally during the build, teams can create an SBOM and put it in the image under bom.json. Then we generate with Sift the software bill of materials. Why do we do that? Because here we just have the application components, and we also want to have, for example, glibc or OpenSSL. We want to know what other things are from an operating system layer in there. So that's why we regenerate, and Swift has the ability to merge these bombs together. We can also say, please exclude this application folder. And then I upload it to dependency track. So there we perform the scan for known vulnerabilities. And then afterwards, because my source of truth is Defect Dojo, I upload it to Defect Dojo. Here, and now we have here dependency track. I think the other things are the same. Yeah, as I said, dependency track has the option to to also handle vulnerabilities, but I'm using Defect Dojo because I have also other scans other than known vulnerability scans. So I want to use Defect Dojo as my source of truth. This is how an information in Slack could look like. So you get an information, your image is older than 60 days, for example, in the Slack channel of that team. You shouldn't put it in the normal Slack channel of the team because at least in the start, they will get flooded with messages. So you should have an extra channel for it. And then highlight this channel should always be empty. In case something shows up in here, you have to react. Yeah, then we have routing. So how does the cluster image scanner know which team to inform? In Kubernetes, I have a label called, for example, contact sdse org//. You can also use your own annotations, and if you have some already. And then you show which Slack channel it is, in this case, fellowship security. So that is where these messages will show up, and the team can react. Maturity models are something very cool. So I give you an overview of what all the things we are achieving with this method which I created. There are also other tools available, especially commercial tools. Nowadays, 2017, 2018 when I started, there wasn't such nice tools available. Nowadays, there are also commercial ones, and I think maybe a few open source ones also, which do something similar. Yeah, but what do we get with these cluster image scanner? We get maximum lifetime for build for images. This is the DevSecOps maturity model with multiple maturity levels, 1 to 4 currently. It will be a fifth one will be added very soon, and then you have different dimensions here. And in these dimensions, we get in patch management on the right, for example, these maximum lifetime. Nightly build of images, indirect, automated PRs for patches, indirect, because developers, after you implemented this, will want to have automatic patches. And they will have a patch policy defined. In testing, you get all the different tests we discussed. Yeah, and when we come to a conclusion, the process is very important. How do you see what is used in production? Often I get the question, we have a registry, and in the registry we scan for vulnerabilities. Isn't that the same? No, it's not, because you don't know what is in production. You don't have the routing information, which team is responsible. All these things are missing. And when you just look at the registry, this information is useless without the context. Yeah, and in addition, you need a vulnerability management system, from my point of view, especially when you use multiple tests. Questions?
Because of the recording, it's better.
Where do you get the information for the vulnerability scans from? Is it like Claire or something?
That is dependency check. In the past, I used dependency check, and now I'm using dependency check. The server-side component with the asset inventory.
No further questions?
Do you have the situation where clients want to load arbitrary images dynamically? so you don't have a fixed image registry.
Yeah, that's no problem. You can also use images from Docker Hub. They are all getting scanned. In case you use Docker Hub, you have the problem of rate limiting. So you might need a Docker Hub account. But other than that, as long as you can configure that there is access to that registry, it doesn't matter what registry it is.
And then if Docker Hub images are used, they are scanned dynamically as soon as they are used in the production cluster, or how do you manage that?
Yes, I'm scanning every day. So every day I scan once. Why do I not scan more often? Because developers already complained when I did it 2 times a day. They said, I want to get the information once in the morning, then I want to react, and that's it.
Okay, thank you.
As far as I understand you, you're advocating for just scanning in production and not scanning on build time, so before delivering images.
That's not what I said.
Yeah, that's good. That's my question. I would think both is necessary.
What I said is, it is better to scan what is in production for known vulnerabilities, but it costs a lot of resources. So in case you want to start, then doing it, for example, with the dependencies check and the Jenkins plugin is better than not doing something.
Yeah, but in the end, I would say we need both. So I don't want to deliver something into production that already has known vulnerabilities, but still vulnerabilities come to light after I delivered, so I need to scan production, of course.
Okay, yeah, now I get your question.
Yeah.
How often do you add dependencies?
I don't do that. I work on another
Okay,
level.
how often do your developers add dependencies to one project? On average, let's say once in a month.
Maybe.
So, let me quickly finish, and then you can raise your question. So as it's just once in a month, I would take the risk that there's one vulnerability, one dependency which has vulnerabilities introduced, which I get only to know 1 day later. Also, developers could perform these scans locally. There are a lot of tools, NPM audit, for example, so they can check it before they commit it. In case you say, I want to know how many vulnerabilities are there for this dependency, which I introduce now, then you can check that beforehand for this one you add. So that's why I only scan production. The overhead to do it also beforehand is, from my point of view, too much. That's why I don't do that.
Okay, thanks.
You had a comment?
Yeah, upgrading dependencies also is quite more frequent, right?
Can you use the microphone?
Yeah. But yeah, I was talking about upgrading the dependencies. Like, it's not frequent to add dependencies, but upgrading them can be quite frequent.
Yeah, that is quite frequent, but when you patch in 99%, afterwards you have less vulnerabilities than beforehand. Not always. I assume there are edge cases, but that is so rare that I wouldn't care about it. I would care about enhancing the process in other ways.
Any other questions? All right. Then thank you very much, Timo.